Welcome back to my channel, dear students. Today I am going to discuss about the Joblonski diagram. The phenomena of fluorescence and phosphorescence are best explained with the help of a Joblonski diagram. Okay, so the process of fluorescence and phosphorescence can be explained with the help of a Joblonski diagram. Okay, to know the Joblonski diagram, here we have some terms to know. Okay, singlet excited state, triplet excited state, internal conversion, inter-system crossing. Here there are two process, radiative process and non-radiative process. Here the radiative process, fluorescence and phosphorescence. Okay, in the non-radiative process, inter-system crossing and internal conversion. Okay, so here when the radiations are incident on a certain substance, some of the electrons may absorb energy and jump to a higher energy level. Okay, when the electrons return to the ground state or which may bring about a chemical change. Okay, here the whole concept is depends on when the radiations are fall on a substance. Okay, so some electrons may absorb the radiations and they may jump from ground state to excited state. Okay, when they are returning to the ground state, so they can be either emits or which release the energy in the form of a heat or a radiation. Okay, if it lost energy in the form of a heat, it is called a non-radiative process, and if it lost energy in the form of a radiation, then it is called a radiative process. Okay, so here when the molecules have a when the molecules have an even number of electrons, see there are two conditions. In the first condition, okay, this is A and this is B. So here in the ground state the electrons are spin paired. Okay, here with the help of a spin multiplicity, that is 2s plus 1. Okay, here the S is known as the total number of electron spin. Okay, in the first case we have 2 electrons, that is paired electrons. So here the paired electrons means we know that the spin plus half and minus half. So S equal to S1 plus S2. So we have plus half minus half, both get cancelled, we will get S equal to 0. Now we have to substitute in this, we will get a 1. Okay, this is called singlet excited state. Okay, it is denoted by S, and the successive energy levels are S1, S2, S3 and so on. So here when you are substituting the S value, you will get a singlet excited state. Okay, similarly in the second case we have a unpaired electrons in a ground state and excited state. So in case of in a ground state we have a similar spin in ground state and excited state, that is S1 equal to plus half and S2 equal to plus half. So now S becomes S1 plus S2, will get half plus half. Okay, that is 1. Now substitute in case 2s plus 1, 2 into 1 plus 1. Okay, it becomes 3. Okay, this is called triplet excited state. The successive energy levels are T1, T2, T3 and so on. Okay, hope you understood. So the singlet excited state and a triplet excited state. Okay, here these S1, S2, S3 indicating the singlet excited state, T1, T2, T3 indicates the triplet excited state. So always the singlet excited state energy will be more than the triplet excited state, so that we are showing S1, S2, S3 higher than the triplet excited state T1, T2, T3. Okay, now when certain radiation fall on a molecule, okay, So when the radiation incident on a substance, some electrons absorb a energy and jump to a higher energy level. Okay, it may be S1, S2 or S3. So when the electron is jump from lower energy to higher energy, that is ground state to excited state. Okay, it is returning in a different ways. You can see here, if the electron is returning to the ground state by emitting a energy in the form of heat. See, when electron is transit from S0 to S1, if it is returning to the ground state by emitting a heat, okay, or by the loss of energy in the form of heat. So that is that this process is called non-radiative process. So if the electron is transit from ground state, that is S0 to S1 or S0 to S2 or S3, okay, if it is returning to the singlet, higher singlet excited state to lower singlet excited state, so by emitting the energy in the form of a heat, okay, this is called internal conversion. Okay, understand? See, the electrons when transit or jump from ground state, that is S0 to either S2 or S3. So see, when the molecule lose energy in the form of a heat, okay, so this is called, means the transition occurs when S0 to either S2 or S3, when it is returning from the higher singlet excited to lower singlet excited state. Okay, this is called in the form of a heat. Okay, this is called a internal conversion. Similarly, so if the molecule absorb energy and the electrons may jump from the lower singlet excited state to higher singlet excited state, when it is returning to the ground state by emitting energy or a loss of energy in the form of a radiation, then this step is called, or this process is called fluorescence. Okay, so here, so there is emission of radiation, so this process is called fluorescence. Okay, the next one, again, when the molecule absorb a radiation and the electrons, means some electrons may absorb the energy and get excited to the higher energy level. So now from a higher singlet excited state to a triplet excited state, the transition occurs from the S2 to T2, that is singlet excited state to triplet excited state, in the form of in the loss of energy in the form of a heat. Okay, this is called internal system crossing. Again, after reaching the first excited triplet state, from first excited singlet state, further transition to the ground state may occur in the form of emission of radiation. Okay, so this step is called a fluorescence. Here both the fluorescence and phosphorescence, okay, the loss of energy in the form of a radiation, so that these two steps are called radiative process. Okay, another internal conversion and inter-system crossing. Okay, here in case of an internal crossing as well as internal conversion and inter-system crossing, the electron may returning to the higher energy level to lower energy by the loss of energy in the form of a heat, so that these two steps or the process are called a non-radiative process. Okay, so internal conversion, inter-system crossing, and I have told you radiative process, the fluorescence and phosphorescence are radiative process, because when the electron is returning to the ground state which lost energy in the form of a radiation, so that this is called radiative process. Similarly, non-radiative process is when the electron is returning to the higher energy level to lower energy level in the form of a heat. Okay, that is in the form of heat. So this process is called non-radiative process. Hope you understood the Joblonski diagram. Okay, if you have any doubt, you can comment, and please subscribe and like my video. Thank you.